You've seen it everywhere, right? AI models like ChatGPT have just exploded into our world. I mean, they can write poetry, they can debug your code, plan an entire vacation. It honestly feels a bit like magic. But what happens when that magic fails? You know, when these incredibly powerful tools get things wrong in ways we totally don't expect. That's what we're digging into today, the hidden world of how we test AI, to find its flaws before they find us.
So, let's start with a little test. Take a look at this question on your screen. The answer seems pretty obvious, doesn't it? Just think about it for a second. You got it? Okay, let's see how the most advanced AIs on the planet handled this.
So did you get it? The answer is 8 apples. He ate them yesterday. And look at this. The world's top models, we're talking Google, OpenAI, Anthropic, Meta, they all get it wrong. Every single one. And this isn't some fluke. As you can see from this data, they trip up on other simple riddles too. It kind of shatters that illusion that they're these perfect, flawless reasoning machines.
And this, right here, gets to the heart of the mystery. I mean, if they can be so easily tripped up by what's basically a kid's riddle, what other, much deeper blind spots do they have? And how in the world do we even start to find them?
So let's dig into that. Why do they fail these simple tests? Because understanding this is really the key to figuring out how to evaluate them on a much deeper level.
You know, for the longest time, the main way we've tested AIs has been with these huge, standardized benchmarks. Think of them like an SAT for models. But as this Reddit user points out, people in the community started to realize that even these major tests had problems, like straight-up errors in the questions. And if the test itself is flawed, how can you possibly trust the score?
Well, that realization really pushed researchers to create a whole new generation of tests. They realized they had to move beyond just simple right or wrong answers and start designing harder, way more reliable benchmarks to really truly challenge these models.
A perfect example of this is the new MMLU-Pro benchmark. What the creators did was brilliant. They took the old test, filtered it down to only the absolute hardest questions, and then had a panel of experts review every single one. And the result? Whoa. A top-tier model like GPT-4o sees its score plummet to just 53%. You see, the goalposts are constantly moving to keep pushing the limits of what these AIs can do.
But here's the thing, and this is so important. Getting a question right on a multiple-choice test doesn't actually mean the AI understands the topic. You have to ask, is it really reasoning through the problem, or is it just an incredible pattern matcher that's seen a similar question thousands of times in its training data?
And that gets to the real core of the issue. Because researchers have found some absolutely fascinating ways that an AI's reasoning can just completely break down, even when it has all the right information sitting right in front of it.
Researchers at Carnegie Mellon found this critical failure mode they called topological ordering. Okay, so what that means is, if you tell an AI a story out of order, like you mention the effect before you mention the cause, the model just gets lost. It blindly assumes that the order you wrote the sentences is the order the events actually happened. It completely mixes up cause and effect.
And the same researchers found another huge problem: parametric knowledge conflict. It turns out AIs can be incredibly stubborn. If you give one a story with facts that contradict what it learned during its training, it will often just ignore your new facts and fall back on what it knows. Even if you tell it, hey, only use the information I just gave you.
And just look at this table from their research. It shows how big of a deal this is. When there's no conflict with its prior knowledge, the AI is super accurate, over 95%. But the second you introduce facts that conflict with its training, look at that drop. Accuracy falls off a cliff down to 48%. That is literally worse than a coin flip.
Okay, so if the standard tests aren't enough and their basic reasoning can be tripped up this easily, how do we find these deeper, more hidden flaws? Well, we have to stop being friendly testers. We have to start actively trying to trick the AI. We have to get adversarial. This whole adversarial approach is called red teaming. It's a term that comes from the world of cybersecurity, where experts basically act like friendly hackers. Their entire job is to poke, prod, and probe the AI from every possible angle, looking for any weakness they can possibly exploit.
One of the most common red teaming techniques is something called prompt injection. Now, a direct injection is pretty simple. You just tell the AI, hey, ignore all your old rules and do this instead. But an indirect injection? Oh, that is so much sneakier. An attacker could hide a malicious command in tiny invisible text on a web page. Then, when you ask the AI to summarize that page for you, it reads the hidden command and gets totally hijacked.
Attackers take this to a whole other level with a technique known as jailbreaking. And one really advanced method is many-shot jailbreaking. Here, an attacker will show the AI a long, totally fake conversation that's just filled with unsafe or forbidden answers. This basically tricks the model into thinking, oh, I guess this is how we're talking now, and it lowers its guard, causing it to bypass its own safety features.
So we have standardized tests, we have these adversarial attacks, but what if the most creative and maybe even the most effective way to test an AI's deep reasoning skills was just to play a game with it?
And that is the whole idea behind this brand new platform called Game Arena. It moves way beyond static questions and hostile attacks. Instead, it uses popular interactive games to measure AI reasoning in a way that's both dynamic and incredibly revealing.
Game Arena has 3 main games. First, there's Akinator, which tests deductive reasoning by forcing the AI to narrow down possibilities. Then, you've got Taboo, which tests abductive reasoning, making the AI form the best explanation from limited clues. And finally, Bluffing tests inductive reasoning, challenging the AI to spot patterns in your behavior and figure out if you're lying.
So here's the interface for Akinator. You've probably seen this before, right? It's the classic 20 questions game. The human thinks of an object, and the AI has to ask a series of yes or no questions to try and guess what it is. To win, the AI has to be smart, asking really efficient questions that logically rule out other possibilities.
And here are the other 2 games. On the left is Taboo, where your job is to give clues to try and make the AI guess a secret word. And on the right, you have Bluffing, where the AI is the one grilling you, trying to catch you in a lie. Each game puts the AI in a completely different situation, testing a different aspect of its reasoning under pressure.
And get this, the results are really surprising. In the Akinator game, where a lower score is actually better, Claude 3.5 Sonnet actually comes out ahead of GPT-4o. This is fascinating. It shows how these different kinds of tests can reveal strengths and weaknesses that you would just never see on a standard leaderboard. So what's the big takeaway here? It's that there is no single perfect test for AI. It's this ongoing, evolving cat-and-mouse game. From tricky riddles to adversarial games, one thing is crystal clear. As these models get more and more powerful, our tests have to get more and more creative.
Which leaves us with one final, kind of provocative question to chew on. As these models get better and better at passing all of our tests, even our games, are we sure they're actually getting smarter? Or are they just getting better at playing the game of passing tests?